Guys, I recently uploaded a video on solving polynomials and solving cubics. This is solving quartics, and there's a few extra things I'm going to add in here to help you understand how to solve complicated polynomials. We're going to start with an easy one and then go on to a hard one. Alright. What makes this easy is it's actually a hidden quadratic. It's actually got x squared squared to give you x to the 4. So if you see you've just got a x to the 4 and an x to the 2, solve it like you'd solve a quadratic. Look for factors of 8 that add up to -6. There we go. And once you get here, two methods. What I like to do is do difference of two squares. What most people like to do is to say, okay, nil factor law. This bracket equals 0 or this bracket equals 0. So x squared minus 4 equals 0 means x squared equals 4. X squared minus 2 equals 0 means x squared equals 2. So x equals plus or minus 2 or plus or minus root 2. Okay, so that's your easy style when it's just a quadratic in disguise. But if it's like this fella, okay, and if it's like got lots of terms in there, there's no common factors, you can't factor it by grouping, it's not a difference of squares, not a quadratic, not a perfect square, nothing like that. What we have to do is do some thinking and some structured strategic guessing. Okay, really it's called an iterative process, not guessing, but it's just glorified guessing. So let's have a look. First thing we're going to do is use this thing called Decartes' rule of signs. So René Descartes discovered a pattern that is helpful for this. If you look at the way the signs, so the pluses and minuses, change. So here we've got one change here, plus to minus, and one change here, minus to plus. Two changes. That means you'll either have 2 or 0 positive real roots. Now if we do f of negative x, so the odd numbers will change to negative, the even numbers will stay what they were. Okay, now we've got plus to minus, that's one change, and minus to plus, that's another change. We've got two changes of signs. So that's 2 or 0 negative real roots. So the solutions to this equation, either we've got 2 real positive and 2 real negative, that's a 4 in total, or we've got no real positive, no real negative, and 4 complex roots. Okay, it's the power of 4, so we have to have 4 roots. They could be 4 reals or could be 4 complex. This is helpful because it can't be 3 reals and 1 complex, or it can't be 3 positives and 1 negatives. It's got to be this. So when we're doing an iterative process, like guessing, if we've got 2 positives already, let's start guessing negatives, etc. Okay. The other thing that is helpful is the rational zero theorem. Now that says if you imagine this factored, it'll be x plus something, x plus something, x plus something, x plus something. All the x's multiplied together will give you x to the 4. All the somethings multiplied together will give you 18. So if there's a rational 0 in there, if one of those numbers is rational, it's got to be somehow related to the 18 and the 1. 18 as your constant term and 1 as your leading coefficient here. So if we're going to have any rational zeros, or if any of our real solutions here are going to also be rational, they're going to come from this list, from your factors of your constant term divided by the factors of your leading coefficient. So we're now going to guess, but we don't have to guess just randomly. We guess from this list of 6 times 2, 12 possible answers. So we're going to try some possible roots, and the first one we're going to try is 1. If we put 1 in here, then we get 0. So 1's a root. Excellent. X equals 1 is one solution. Because that went really quick, let's try a couple others. No, 2 doesn't work. Oh, 3 does work. Excellent. Okay. Now I'm being a bit facetious there, but always try 1 and -1 first. If they work, that's great. If they don't work, keep trying. Or here's what you could do instead. Now before I get to that, I've got 2 positive roots, 1 and 3. So what that means is I'm looking for 2 negative roots. I got no complex. Okay, these are only the 2 situations we could have, and it must be that first one if I got 2 positives. So what I'm looking for in factored form is these 2 values here, and they've got to be negative numbers. What'll help me is if I take my original function, divide by x minus 1. Okay, I'm going to use synthetic division here. And now I've got a new polynomial here. That's my remainder 0, so there's my new polynomial. I'm going to divide that. Sorry, I'm going a bit fast. That's 1x cubed, 2x squared, minus 9x, minus 18, no remainder. If I divide that by the x minus 3 here, I get a quadratic, 1x squared plus 5x plus 6, which I can easily factor. So now what I've done is I've factored my original quartic here. Now the question asked me to solve it, so there you go. My solution is x equals -3, this one, -2 from this one, 1 from here, and 3 from here. Okay, so that's how you would solve a quartic. Now, because this has a leading coefficient of 1 and 18 is not that big a number, it's not the most difficult quartic you might come across, but this is, even with more difficult ones, just follow the same method using your rule of signs and your rational zeros theorem, and you'll get the answer there eventually. Good luck solving quartics!